Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he's doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here, and thank you for XLR for teaching us.
Hello guys, good evening. I hope I'm audible and the screen sharing is also working. Can you confirm that with a yes in the chat box? Hope I'm audible and the screen sharing is also working. Done? Yeah. So welcome to the last day of training. What happened? Zoom closed down. Oh, not there. Yeah, welcome to the last day of training, and yeah, so if it breaks anywhere, just let me know. I'll try to adjust it. Okay, done. Yes guys, so we'll get started. We will go through the last question that we were seeing yesterday. That was min minimum depth, okay, min depth of a tree, min depth of a tree, coming to the minimum depth of a tree, copy the same max depth function here. Okay, this will not work. If you just write it as min, this will not work, because you see here, minimum depth in the sense, people generally think that, let me zoom out a little bit and we can make full screen as well. Okay, people generally think that minimum depth is kind of like okay, a root node which is null value. No, root node to its leaf node. Okay, what is a leaf node? Last node which doesn't have any children. Okay, that's what we call minimum depth here. Done. See, if you observe this particular test case here, it has 2, then left is null, right we have 3, again left is null, right we have 4, again left is null, 5, again left is null, 6. In this manner we have. So the minimum depth is the distance from root node to its leaf node. That's what we call minimum. That's how min depth will work. Now let's see here. If now, based upon this particular analysis that we have, what we'll do is, if like, let's come out of it, if root dot left, if root dot left is equal to none, okay, if root dot left is equal to none, then we will return, 1 plus self dot min depth of root dot right. Okay, if left is not available, you need to go to the right path, and same goes with right as well. Same goes with right as well. Copy this. You can simply write it as if or elif, it doesn't matter since we are keeping a return there. Okay, if root dot right is null, if right is not available, you need to go to the left part. Okay, we need to find a path from root node to its leaf node, right? That's what we have. So if left is not there, you need to go to right. Right is not there, you need to go to left. If both of them are there, you need to go with the minimum of these two values. Minimum of these two values. Minimum of these two values in the sense, maybe I'll make the call here. Copy it. Min function. Paste it. Again, copy this one. Copy it. Paste it. Okay, that's it. That's the min out of it, and yeah, 1 plus we have to write, whichever will give us the minimum distance, that is where we will be going through as well. Okay, that's it. Now let's try to run it. Let's see if there are any issues. Done. This is fine. Now submit it. Accept 35%. Okay, fine, because recursion, maybe it's taking more time. It should generally give us a little bit more. Yeah, 32. Let's see what the 0 millisecond guys did. They used AQ, BQ. Let's see any other person. They also kind of did something similar. Since we are using regression, maybe it's taking a bit more time, but generally we should not get that much of issue with it. Yeah, you see now it's 58%. Maybe some sort of internet issues every time. As I told you, that compiler doesn't work properly now, like that time complexity one is not working properly. That's it. That's the last question in trees. Okay, and you see today's topic is graphs, so we will go with graphs. But before we go through that, okay, since it is the last day, yeah, just so that we are connected in the future, this is my LinkedIn. If you want to get connected with me, you can send a connection request or a follow request. I'll post it in the chat box. Okay, you can click on it, or if you guys want, you can also scan this QR that you are seeing here. You will be connected with me. It doesn't matter. At whatever requirement you have, you can always get in touch with me. Anything related to DSA, anything related to your campus, your career, if you want to talk about, I'll be always there. I'll help you. I'll give you good suggestions. So that's it. I've posted it in the chat box. This is the QR as well. If you want, you can scan it or take a screenshot of that. That's up to you, right? So it's the last day. So we will quickly go through graphs first, and we will try to implement depth first search and breadth first search. Okay. Now let's check it out. Let's see some graph related content. Let's see some graph related content. That is it. Yeah. Then you see, coming to graphs, I don't have the updated presentation, so we'll get with this. Now, what is a graph? You see, graph is a finite set of nodes with edges between the nodes, okay, with links between the nodes. Or you can formally define a graph is a structure of V comma E. V stands for vertices, E stands for edges, okay. So that is a pair of x comma y, means the link between those two nodes. We'll see that, don't worry, we'll again come back to this definition if you do not understand it. Now let's say given a map of any area, you have seen Google Maps, that's one of the better examples. You have multiple locations, multiple latitude, longitudes, okay. So those multiple locations we have, those are our nodes, we will say. Now, if I want to go from any order, like from one place to the other place, okay, if I want to come up with any relationship between them, okay, minimum distance or what are the other factors that I have to consider, etc. and all, if you want to check, graphs will give an idea, and we have a lot of algorithms in graphs, okay, so that will help us to brainstorm all these real world situations. Now, if you connect all of them, okay, that's what we call edges. These are all our vertices. If you have some sort of weights added to them, kind of like for A to B, if I have to travel, I have to spend 6 rupees. From B to C, if I have to travel, I have to spend 7 rupees, or let's say they are kilometers, okay. In that manner, that is the cost of traveling from A to B. That's what we call weighted graph. We will be able to add a lot of relationships in this manner, okay. If you take it out, this is what we actually go through. Say everywhere. Coding, you see, it's not any natural phenomenon. We are the creators, we are the gods. So whatever you are seeing, okay, whatever you are learning in coding, they all have been inspired from real world situations. They all have been, okay, used in real world scenarios. By using them, by inventing a way of solving, a way of doing something, an algorithm, a data structure or something, we are bringing some benefit, okay, some optimization, some way of easing things, okay, related to any application or software. So that's what we do. We have graphs everywhere: protein interaction, world wide web, the power grid, internet, everything, okay, is graph. Now, this is a simple graph. You will be having a graph is a combination of vertices and edges, okay, nodes and edges. V stands for vertices, those blue dots are nodes, those red lines are our edges. And you see, the edge is nothing but it's a combination of two nodes. For example, we have a U node and we have a V node. I hope you can observe them. Okay. If there is a link between them, this E is a set of that X comma Y, that U comma V we have. Okay. That's it. And directed graphs means, you see, undirected means you'll not have any direction. You have a link from U to V and V to U. Directed graph means you'll only have one direction, one link in, a link in one direction, means you'll be having only a link from U to V. Weighted graph means you will be having some sort of trade-off, okay, some sort of expenditure in that manner in order to go from one node to the other node. Now, what is a cycle and what is a loop? Okay, you see here, cycle means if multiple nodes are connected and if you can reach a node, okay, through traveling other nodes, that's what we call as a cycle. If a node is connected to itself, that's what we call as a loop. This is the terminology. What is graph? Collection of nodes and line segments, edges, vertices and edges, we can say. Vertex, that's singular, and plural is vertices. A node in a graph. Edge, a line which connects two vertices. Directed graph, if you have an edge with a direction. Arc in the sense, okay, the edge in a directed graph is what we call as an arc. Now, undirected graph, if you don't have, the flow can go either way. Adjacent vertices, if you have two vertices, they are said to be adjacent if there is something which connects them, if there is an edge. What is a path? The collection of all the edges connecting from certain nodes. For example, if I have to reach F, there are two paths, or there are, yeah, two paths. I can start from vertex A. I can start from vertex A, I can travel to vertex B, I can travel to vertex C, I can travel to vertex F. This is one path. Now there is another path. Okay, what's that another path? I can start from vertex A, I can go to vertex B, I can go to vertex C, I can go to vertex C, I can go to vertex F. I can travel this path. This is what we call as path. Okay, path in a graph. Right. Now, what is a cycle? Cycle means a path consisting of at least three vertices that starts and ends with the same vertex must follow a proper direction. Okay, directed. It's a special case of cycle in which the single arc begins and ends with the same vertex. You have seen the example here. That's a cycle, that's a loop. Okay. Now, terminology, connectness. If two vertices are said to be connected, if there is a path between them. Directed graph is strongly connected if there is a path from every vertex to every other vertex. A directed graph is weakly connected if there are at least two vertices that are not connected. A graph is disjoint if it is not connected. Don't worry, look at this example. This is strongly connected. Every node is connected to some other node. This is weakly connected. Last nodes are not connected. Okay, G is not connected to anything. Okay, this is disjoint. There is a sort of connection missing in between both of them. Okay, this is what we call disjoint. You see, strongly connected, weakly connected, disjoint. That's it. That's about connected graphs. What's a degree? Degree is nothing but the number of nodes that are connected to a specific node. Okay, number of edges that we have for a node. Out degree means how many connections that are going from that particular node. In degree means how many connections are coming to that particular node. For example, if I go back here, okay, you see what is the degree of this E node? The degree is 4. There are 4 arrows, 1, 2, 3, 4. What is the in degree? In degree in the sense how many are coming into it? You see 1 and 2. What is the out degree? Out degree is 2. How many connections are going out from it? That is also 2. You see 1 and 2. Okay. That's what we call in degree, out degree. This is all the terminology. Okay, so this is all the terminology. Done. There are two ways of representing a graph. First one is what we call as adjacency matrix representation. Second one is what we call as adjacency list representation. Okay, I would generally love to go through these representations and show you everything, but these will take a lot of time. And since we have not gone through any matrices and a lot of beginners are there, I don't want to confuse anyone. We'll just see how they work without coding them, and then we will also go through what we have. Depth first search and breadth first search, those two are important. Once we complete them, I think we will be done with the time as well. And you have a sort of MCQs exam today, so we will be ending at 8:15 actually. Okay, so we don't have much time, so we have, I think, mostly some 40 minutes or so, 40-50 minutes or so. So yeah, we'll see what all we can cover. Okay, now coming to adjacency matrix representation, you see, if I have a simple graph in this manner, there are three nodes in my graph, A, B and C. Okay, write all the nodes in your row and the column. Okay, take a n by n matrix, row, node by node matrix, or V by B matrix, you can call vertices, you can call it. A, B, C, these are the node numbers. If A is connected to B, you will be having that particular connection as 1. You see, A and B are connected. There is a link, so this is marked 1. A and A are connected, no, so 0. A and C are connected, so it is also marked 1. Now coming to B, B is connected to A and C. C is connected to, okay, A and B. That's how. That is adjacency matrix form. That is V by V matrix, you will have V square. Now adjacency list, you will be having a linked list, okay, with links to all of its nodes. For example, we have a linked list of V nodes. A is connected to B and A is connected to C. B is connected to A and B is connected to C. C is connected to A, C is connected to B. You can write them in any order, that's fine. So if we have a directed graph, you will be able to see the difference. If you do not have a directed graph, write it in any order. Okay. Now let me see. Coming to this presentation, marking one and not undirected, you will be from I to Z. If it is direct, you will be only having on one side. Let me show you. See, this is a example for adjacency matrix one. Okay. Now see here, this is the graph I have. This is the graph I have. Okay. Right. So I have the node 1, 2, 3, 4 and 5. How many nodes I have? 5 nodes. Okay. I have taken a matrix of size 5 by 5. First node, second node, third node, fourth node, fifth. And 3. 1 and 2. I have marked 1. 1 is not connected to 4, 5 and all. That's why 0. Same thing to mark. Yeah, sorry, got disconnected. Bad network every now and then. Okay, bear with me for 30 more minutes and it will be done. Yeah, what we were talking about is we were talking about how to represent it in adjacency matrix form actually. Okay, now coming to this matrix form, whenever you have a link between them, you will be marking it. If it is undirected, you will have mark from I to J and J to I as well. If it is directed, you will have mark in only one direction. Okay, that's how it will be. Just a second. Done. You'll have only from one direction. This one here, adjacency matrix example, a matrix of 5 nodes. I have to take a 5 by 5 matrix. Sorry, I have a graph of 5 nodes. I have to take a 5 by 5 matrix here. Now there is a link in between 1 and 2. So we have 1, we have to mark it as 1. There is a link in 1 and 3. 1 and 3, mark it as 1. There is no link between 1 and 1, 1 and 4, 1 and 5. In this manner, I have to keep on adding it. And 2 is also connected to 1, 4, 3. So you see 2 is connected to 1, 4 and 3, right? So this is undirected. So you will have links on both the sides. Giving a graph as a set of V comma E. You see here, these are the vertices. These are the edges. Now edge is from where to where you are connected. 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 5, 4 to 5 in that manner. Okay. Graph is a finite set of V comma E for vertices. E stands for edges. Okay. Done. Now next one, we have adjacency matrix example. Same, but this time directed. Now direction means you will be having only one direction, one thing. For example, you see, okay, 1 is connected to 3 here, 3 is not connected to 1. You see, 1 and 3 have a link, but doesn't have any link. Okay, done. That's it. 1 and 3 have a link and 3 and 1 doesn't have a link. This is about directed. This is how adjacency matrix will look like. Now, what are the pros and cons of it? Representing a graph in the form of adjacency matrix form is easy. You can easily tell if you have an edge or not by simply checking that vertices, okay, I comma j. If it is 1, you have an edge. If it is 0, you don't have one. Now, the disadvantages is you need to have n square memory. For example, if I have a graph of 5 nodes, I need to make a matrix 25, 5 by 5, 25, n required more, but implement easy. Okay. Next step. Now see, coming to adjacency list form, we'll be taking a linker list where every node represents every node represents a node in our graph, and it will be the head node for the rest of the values. For example, see, okay, the first node, second node, third node, fourth node, fifth node. Okay, 1, 2, 3, 4, 5. Now 1 is connected to 3 and then 1 is connected to 2. You can just go in the order, and even write 3, 2, doesn't matter. So 1 is connected to 2 and then 1 is connected to 3. So this particular one, this is the head node. Okay, you can consider that's the head node, and it is going to point out to all the list elements. We are going to again connect this to other linker list values. Okay, so that contains the head value, that contains where the all other nodes are present. Okay, this is how adjacency list form will look like. If it's directed, you'll only have one-sided link. If it is undirected, you'll be having both side link. That's how it will be done. You see, undirected, we have both side link. Clear, right? Now let's talk about pros and cons of adjacency list. You will be able to save memory, okay, but it is going to take big O of n in order to access how many edges you will have. Okay, you need to access through all of those links in order to just check if there is a link in between 2 to 3, 2 to 4 also. So identifying if there is a link will take time, but memory will be less occupied. This is how you can use this one. So this is how the complete time and space complexities will look like. Memory, you can see, matrix will take V square, adjacency linker list will take V plus C. To check whether there is an edge or not, you will take only constant time complexity in adjacency matrix. Okay, but in adjacency list, you will take the degree of it, how many nodes you are connected with. You need to go through all of them. Okay, in that manner. This is how the pros and cons are of graphs. Now, if you want to traverse a graph, if you want to search for any element, there are two types of it. So we have depth first search and we have breadth first search. Now, what is depth first search? We will first try to go as deep as possible. Okay, as deep as possible. Then we'll come back, we'll go with the next path. Now, breadth first search is kind of like level order traversal. Okay, we will be going through each and every level. Okay, these are kind of easy. We will use the stack for first implementation, depth first search. We will use queue for the second implementation. This will look very easy, but there are other sorts of implementations that can go a little bit difficult. So I've selected the easy ones only, so that you as a beginner will be able to get started with it. Okay, in your preparation. Yeah, coming to BFS and DFS. Okay, breadth first search. First, you will try to go as deep as possible. Okay, then you'll again come back. You will again visit the nodes that you have not visited. Depth first search. Sorry, breadth first search, you will be going through the neighboring nodes. Okay, first 0, then 1, 2, 3. You will access everything in the first level. Then you will access everything in the next level. Depth first search, you will try to go as deep as possible. 0, 1, 4, 0, 1, 5, 0, 2, 6, 0, 3, 7. Now, if you observe, sir, we have been talking about graphs, right? Where did trees came from? Yeah, actually, most questions in graph, what we will do is, we will remove the circle. Is closed paths. Trees will not. Graphs will have closed paths, but trees will not have any closed paths. Okay, we will remove that link from the graph, which makes it as a closed one. That loop, we will work with it like a tree. Let me tell you one more. We convert the trees as well to problem solving. There are lots of things that happens, but anyway. Yes, so depth first search works. Just have a look at it. I'll just show you, okay, the implementation of it. We'll go through that. We'll go through depth first search. Just have a look at it. Depth first search. Done. You see, select an unvisited node, visit it, then treat it as a current node. If an unvisited neighbor of the current node, you have to visit it and make it as new current node. You need to again do the steps 3 and 4, okay, until all the nodes are visited. Or let me show you how it looks like. You can start with any node, okay. Let's say I'm starting with this one. Now, if you have not visited any of the nodes, you can go as far as you want. For example, let's say I'm going to visit the other node here, okay. Then from here, you can see the direction. I can only move in one way, this one. And from here, I can only move in one way, this one. So we have gone as far as we can. Now, can I go and visit any other nodes from that point? No. You will mark it as visited. Then you will again backtrack. You will come back here. There is any other node that I can visit from here? No. Mark it as visited. You will again backtrack. Is there any other node that you have visited from there? No. Can you visit from there? No. So mark it as visited. You'll again backtrack from the to the original one that you have. Is there any? Yes, there is one more node. Is there any other node that you can visit from here? Yes, there is one more node, right? Now, is there any other node which you can visit from here? No. Mark it as visited. Now backtrack. Is there any other unvisited nodes from that point? No. Backtrack. Is there any other unvisited nodes for that node? No. That's it. That's what we call depth first search. We'll try to go as deep as possible. If you want, you can also kind of make it as a tree representation to check it. Let me try and show that to you. Okay. Let's say we are trying to make it as a tree. So we have this A. Okay, we have this one, let's call it C. We have this one, let's call it D. Let me write them here only. A, B, C, D. Okay, now A is again connected to one more node, that is what do we have, E, and E is also connected to one more node, that is F. Okay, let's imagine in this manner. Let's imagine we have it in this manner. You also have the links from other nodes as well. For example, you see A is connected to, this is E, this is F. A is connected to B and E. Now E is connected to F, but E is also connected to C. So I'll write it in a very light manner. So just to show that to you as a tree. Now B is connected to C, and is there any other connection? Sorry, E is connected to B as well. Okay, I'll write it very lightly. Okay, done. This is how the connections are. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 7. Okay, done. Now see here. First, our strategy is to go as deep as possible in the sense the maximum depth I can reach. So first, I'm selecting this A as my starting node. A2 I'll go with B. I'll go up to C. I'll go up to D. I cannot go anywhere from D, so I'll mark it as visited. I'll again backtrack. I'll mark it as visited since I cannot go anywhere from here. I'll come back. I'll mark it as visited. I cannot go anywhere from here. I'll come back. I'll mark it as visited. Oh, sorry, I'll not mark it as visited. I have E to go here and F to go. Then while coming back, I'll mark them as visited. That's what actually happened there. So let's undo all this stuff and then try to see that. Okay, done. In that manner, you can visualize it. Let's look here. First, we have A, travel to B, C, travel to D. From D, I cannot go anywhere. So visited, come back. C, I cannot travel anywhere, visited. B, I cannot travel anywhere, visited. A, I cannot travel, sorry, A, I travel to E. From E, I can travel to F. Now again, from F, I cannot travel to anywhere, so you can mark it visited. Same goes with A as well. So we will be doing it. And first, select unvisited node, visit it as current node. If there is any unvisited neighbor of the current node, you have to visit it and make it as a new current node. If the current node has no Yeah, sorry, my bad. As I said, this is a new place. I don't have proper internet connection. But anyway, I think we have seen this. I think I have started this one. So did it break, or have you listened the previous one, like this tree that we have written, etc. and all? Then I came back. This is where it got disconnected, right? Can you please confirm that? This is where it got disconnected, right? Done. So see, we'll select a unvisited node, we'll visit it, we'll treat it as the current one. We will find any unvisited neighbors that it has. We'll visit them, we'll make that as the current one. If there is no other node we can visit from there, we will backtrack to its parent. Okay, we'll again repeat these 3 and 4 steps until there are no unvisited nodes that are left. Okay, and this what we have. See, let's leave depth. We will be happily using a stack in order to visit the last node. You see last in first out now? Last in first out. Last visited node is the first one we will go back if this is available. Okay. So we'll create a function called depth first search. They will give us a starting node. We will mark it visited first. From each vertex directly reachable from you we will search for any other reachable nodes. If it is unvisited, we will call the depth first search again. If it is already visited, then it will not call it. Okay, this is how it is going to keep on doing it. You have seen recursion, you have seen the problem solving capabilities of it. It will visit the last visited node, last in first out. Recursion by default uses stack data structure. Okay, let's see for depth first search and lead code. Let's see if there is any depth first lead code. Okay, we will directly go with the recursive calls. You will understand it. Okay. If it is not there here, we'll go with geeks for geeks. It should be present. It's very important. So do we have anything? Okay, maybe it's not there in lead code. Let's try to Google it. Let's see if Google gives us anything. Maybe, or this is a blog. Maybe we don't have it. Well, let's not waste any time. Let's go with geeks for geeks. Geeks for geeks will have every single question. Okay. Geeks for geeks will have every single question. So we'll go it in this manner. Depth first search. Practice, maybe if I click on it, I'll get practice. This is going to give us blog maybe. Let's go with practice. Depth first search in graphs. Okay, yeah. A DFS of graph, we have the practice. It's taking some time. Maybe because of my poor internet connection. Let's see, yeah, we got. Yeah, and a connected undirected graph containing V vertices. You can see these are the V vertices, and represented by a 2D adjacency list, okay, where I represents the list of vertices. Perform a depth first search traversal starting from vertex 0. This vertex 0, vertex 0. This is 2. Starting from, okay, 0 is the vertex. What is this? 2, 3, 1 they have given? 2, 3, 1. What's the meaning of visiting depth first search? You see, so 0 we will start, we will go as deep as possible, we will go to, let me expect, we will go to 2, we will go to 4, 0, 4. We'll back since it is visited, we cannot go anywhere from here, we'll come back, we cannot go from here. 3, so 3, we cannot go anywhere from here, visited, backtrack, we cannot, can we go anywhere? Yes, visited, come back, we cannot go anywhere. So yeah, 0, 2, 4, 3, 1. That is how everything is mapped. Now the same thing, let's try to write a recursive code for it. So they have given us the adjacency matrix form, I think. Let's try to make sense out of this one. Okay, they have given something. I generally do not open Geeks for Geeks that much, but let's see. This is 2, 3, 1. Given containing V vertices where adjacency of I vertices connected to the vertex. Oh, done. Got understood. You see, the vertex names are nothing but the indexes here. This is 0, this is first, this is second, this is third, this is 4. You see, 0th vertex is connected to, okay, 2, 3 and 1. One vertex is connected to 0, means 1 is connected to 0, this connection. 2 is connected to 0 and 4. 2 is connected to 0, 2 is also connected to 4. So this index is our vertex. Okay, and the value inside the index is the, what do you say, are the nodes which are connected to it, are the edges of it. Okay, that's what we have. So now they have given us this adjacency matrix. We need to perform depth first search for it. Okay, now maybe depth first search, we will also try to send one more we'll also try to send one more list to it. Let's think about what we can do for it. I'm just thinking to make it easy for you. Okay, as a beginner, this is one a bit difficult to understand at the beginning. What should we do? Should I send V as a vertex, or can I go with direct DFS? That's what I'm looking for. One thing I was able to figure it out. Okay, the size of pieces will be 10 to the power of 4, so it's gonna be a little bit bigger. So that's okay. Let's get started. Maybe we will go with vertices. We'll go with vertices. You see, let's take a normal set called V. Okay, V is equal to, first we need to know how many nodes are there. So I need to mark them, the process, I need to mark them as visited or unvisited. So first I'll take the length. You see first value, second value, third, 4, 5. So we have 5 nodes, 1, 2, 3, 4, 5. Okay. So first I'll take 5 nodes. I'll take a list. I can even go with Boolean values or 0 or 1. 0 represents it is unvisited, 1 represents it's visited, or better to take Boolean value, because I'll take a array of all false. Okay, false means it's not visited. If I'm visiting it, I'll make it as true. Okay, that's how I'll know if I have gone through that particular node or not. I'm just accessing each and every element, so that's how it will be. So first, number of vertices is equal to length of ADJ. Okay, you will get the number of nodes that you have, vertices that you have. Now you will make an array called visited. Visited is equal to, let's go with false, multiplied by v. You will node number of values inside your visited. Every node is not visited now, so I'm making it false by default. Okay. Now in order to post the result as well, result is equal to, we will take an empty array. This is where I'll be placing all my vertices which I'm accessing. Now we just need to access each and every node. Since they said, okay, start from the 0th node. If you observe here, start from the 0th node. They have mentioned it somewhere. I forgot it. See, from vertex 0. Vertex 0 means the value, the node presented 0th index. So here, I'll call another function. I'll call traversal or yeah, traversal only. Traversal start from 0, and everything will be added into this result only. So here I can happily return that result. Did I say do traverse in the orders? They are given in the return a list. Yes, we have to return a list, so we are returning the result. Now let us write this traversal. DEF traversal of, here we are taking this node, done. Now the process is simple. You have seen that 5-step algorithm na. If I'm accessing a node, this is the current node. I have visited it now. So I'll access this node value inside my visited array. Visited of node will be modified to true. Now I have accessed it, so it's visited. I made it true. Now I need to check which nodes I am connected to. Now how can you get that? You see, you have your adjacency 2D listener. If I'm giving you 0, adjacency of 0 will give you what other values you are connected to. We just can access it happily. So nodes we are connected to is for will can say neighbor and adjacency of node. If I say, you see what this is going to give me is adjacency of 0. You see, for the first time node is equal to 0. So what my visited for this one is 5 na, so I have 5 false. I'll just write it as F and F. Okay, now I'm making it as true. Okay, so which one I made it as true? For the 0th index I have visited it, so made it true. Let's also add it in our result depend of node. Okay, now you see in our result 0 is added. Now what are the neighboring nodes of adjacency of 0? These are the neighboring nodes. I'm trying to access 2, 3, 1. Now I'll go with 2. Okay, I'll if it is not visited, I'll keep on doing this. Now you see, if ADJ of, sorry, not ADJ, if visited of neighbor in the sense 2 is equal to false. If I did not visit it, did I visit index 2? No, it's not visited. It's currently marked as false. Then I have to visit. I have to call this function again, traversal of that particular neighbor node. So that is neighbor. Okay, this is how I have taken it. Again, same process. It will keep on doing that until everything is visited. Everything will be added into your result.append, and ultimately we are returning it. So this is recursion. So it will keep on doing it. Recursion, as I said, whenever you are doing a recursion, forget about the previous iterations. You see, I have written it here as well. Visit an unvisited node, treat it as your current node. Find an unvisited neighbor of the current node, then make it as the new current node. Forget about you had that as previous, it will automatically link. So that's how the beauty of recursion is. Now let's try to compile it. We will definitely get an error. No, I'm surprised we did not. Now you can submit it. Let's see. Mostly this is the easiest solution by far. You see, all 1120 test cases, all 1120 test cases passed. Okay. That's about first to try to sync these 5 points with whatever I have shown you. Okay. It will automatically. Internet is unstable, so don't worry. You can take a screenshot of this one. You can take a screenshot of this one. Okay. This one. Done. Done. Depth first search, and I have written comments here so that you guys understand what's happening if you go through these steps as well. Okay. Now same thing. Let's also go for breadth first search for that question. I hope you have taken a screenshot. First search. This. Okay. I'll show you that. We will talk about this, so I'll try first. Now see, let's say we have this directed graph here in this manner, directed graph only for easy thing from 1. Whenever you are accessing anything, add to your queue. Okay. Next, 1 in your queue. What all other nodes you can access from 1? We have 3, we have 4. Select any, whatever order they are giving, select it. 4 is in the order, so 4. Add it in the queue. Now from 4, like after 4, we have 3, so add it in the queue. Now do we have any other nodes of 1? No. So from 1 I cannot go anywhere, so 1 is visited. I can dequeue it, I can remove it from the queue. What is the next value in order? That is 4. From 4 can I go anywhere? Yes, I can visit 5, add it in the queue. From 4 can I go anywhere else? No. Remove 4, dequeue it. Okay, you can go with the next one. Now from 3 can I go anywhere? Yes, you can go to 2, add it in the queue. From 3 can I go anywhere else? No. Then mark it as from the list. Remove. From 5, yes, I can visit to 6, add it in the queue. From 5, can I visit anywhere else? No. So mark 5 as visited and remove it from the queue. What is the next value in the queue? 2. No. Mark it as visited, remove it from the queue, dequeue it. From 6, can I visit anyone? No. Mark it as visited and remove it from the queue. You will come out of the queue, and that's it. That's breadth first search. Okay. Realize it. This is what I would like you to do. Yeah, maybe let's first access them, then I'll have better clarity. They will give you in the question, that is the order that we have to follow. We have 1, and after 1 we have 4, after 4 we have 3. Okay, 1, 4, 3. Then we have 3 is connected to 5, 3 is connected to 2. Sorry, that's 4 now. Maybe I'll clear everything. We have 1 is connected to 4, is connected to 3. Okay, 4 and 3. Next we will say 4 is connected to 5. Okay, 3 is connected to 2. What else? Where else 3 is connected? 3 is also connected to 5, so we can ignore it. 5 is connected to 6, so we'll get 1, 4, 3, 5, 2, 6. Yes. Okay, you see breadth sorry, yeah, breadth first search. Done. Imagine it's in this form, and we have the other links as well. It's not like 1 and 4, 1 and 3 are connected, and 4 and 3 also have a connection. 3 is going to 4, but this is not required. So we are accessing breadth first. Okay. As a tree form, you can visualize it in that manner. You don't have to take it that much seriously. Okay. Now 1 visited. Now next we'll go with 3. We'll add them in the queue. Now from 1 I cannot go anywhere else, so everything is visited from 1. So mark 1 as visited, remove it from the queue. From 4 the same thing, I can go to 5 but I cannot go anywhere else, so 4 is visited, remove 4. From 3 I can go to 2, add it in the queue. From 3 I cannot go anywhere, mark it visited. This process will keep on repeating for everything. Now see here the implementation of it, see the algorithm, see the sorry, got disconnected again. Okay. Yes, so we talked about breadth first search, right? So let's quickly go implementation. Now, 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 see here, breadth first search effect. I have opened it in. Okay. Sorry. Geeks. Same version, they are going to give us a graph, they are going to give us that are linked to it. Okay. So we are going through the breadth first search implementation, just like the depth first search. They have given us a graph, they have given us a graph, and we also have, okay, right? So we just need to implement breadth first search here. You just need to implement breadth first search. Yes, yes. Just waiting for the connection. Like sometimes it will fluctuate, so just waiting for it to be correct. This is the last 10 minutes, so I'm hopeful we'll be able to get that. Now, whatever, everything is fine. Now you are able to hear me. Now you are able to hear me. Okay. Yeah, just an implementation. Let's check it out, and once we are done with it, then fine. So what I was telling is, this is depth first search question in Geeks for Geeks practice. They are giving us a connected graph. You can see that. Same matrix representation, vertical 5 vertices. Okay. These 2, 3, and 1. This is the order. So if I use breadth first search for this, okay, you see, first I'll visit 0. I'll add all the, first I'll visit 0. I'll add values in the first vertex that we have to visit is vertex 0. They have given only vertex 0 here, this one only. So vertex 0 I have visited, I have added it. So in the answer also you can see. From vertex 0, I can go to 2, I can go to 3, I can go to 1. I have to add all of them. Can I go anywhere from vertex 0? No. Mark it as visited, remove it from the queue. So in the answer, you will get 0 first. After 0, what else you will get? You will get 2. Now from 2, can I go anywhere? Yes, we can go to 4. So add it as 4. Okay. Now from 2, can I go anywhere? No. Remove it. So you see 2 is visited, 0 and 2. Now 2 is done. Now we will go to the next one in our queue, that is 3. From 3, can I go anywhere? From 3, can I go anywhere? No, 3 doesn't have anything. Sir, how do you know that, sir? You see, this is 0, this is 1, this is 2, this is 3. 3 only has link to 0, so no other link. So I cannot go anywhere from 3. So 3 is visited, remove it from the queue. You can also see 0, 2, 3. Now same thing, in the order we have 1. From 1, can I go anywhere? No, 1 is visited, remove it from the queue. What is the next value in queue? 4. 4, can I go anywhere? No. Remove it from the queue. 4. Now the queue is empty. Queue is empty. If it is empty, your program is completed. If it is not empty, take the first value, add all the unvisited nodes from it into the queue, and repeat the same thing. That's all we have to do. So let us try to implement this as a queue or so. Let's try to implement this. Use the collections module DQ for it and go with the last one. So we will again take something called visited. Visited is equal to, I need to know the length of the adjacency matrix. False into V. These are all my vertices. Now result is equal to empty we will take. This we have taken it for the previous question as well. So this is fine, I guess. I hope you will understand it. Now we will be taking a queue in order to append and delete all the values. Collections module, or we can even simply use a list as a queue as well. So queue is equal to empty list. Node. Since we are starting from the 0th node, like recursive function. Okay. Since we are starting from the 0th node, I'll say visited of 0 is equal to would be very bad internet connection here. Sorry for that. These 3 days issue. Yeah. So true. We have appended that into our sorry. not, yeah, we have appended that into our queue. If queue is not at all possible from this particular 0th node, where do we have them? Inside ADJ. Okay, so for neighbor in ADJ of node, if it is not visited, if that neighbor is not visited, if visited of neighbor is equal to false, if it is equal to false, I'll mark it as visited. Visited of neighbor is equal to true, I'll mark it into queue. Okay, so queue dot that neighbor. Okay, added it into my queue. Once I am done with everything, once I am done with all of them, okay, we will just simply come out of it. We don't even have to dequeue since we are accessing everyone in the same order. We will just come here, we'll return result. Okay, okay, sorry, yeah, result. Yeah, here before going, we'll mark, we will append it into the result dot append of result dot append of. We will, yeah, let's pop it, then only queue will become empty now. Let's pop the value from the queue. So what I'll do is we will go with q dot pop of index 0. Okay, this is the node that we are popping. Yeah, node, this is where I'm getting it. I just went on after the signal disconnected. First I'll append it, then I'm marking it as it's already marked as visited, so everything will be fine. Now let's compile and run it. Yes, sample test case is fine. Let's try to submit it. Done, attempt successful. So take a screenshot of this one and let me try to see that presentation. There I can show you that algorithm as well. Just remember this queue implementation there, then you will be able to easily do it later. Watch this again, recording, then try to attempt it. We don't have much time, so I'll kind of end it in this manner. I cannot move. Yeah. Okay, guys. So take a screenshot of this one. Take a screenshot of this one. Okay. Same thing. We are taking out how many vertices is unvisited. We are using queue here. Okay. First, we have to start with 0. So we are making 0 as true and we are appending that into our queue. If the queue is not empty, we will remove the first value. We will add it into our result, just like the explanation I have shown you. Just compare that one to this one. You can watch the video again. Whatever neighbors that I have for that particular node, I'm marking all of them as visited if they are unvisited, and I'm adding them into my queue. And this process will keep on repeating until I have removed all the elements from the queue and accessed all those neighbors that it has. Okay. Take that graph, just plot it here, take that queue and do the tracing just like I did a little bit earlier, okay, 10-15 minutes back. You will be able to implement breadth first search as well. So these two are important. These two are very, very important, okay, moving forward. And that's it for the entire 15 days, 30 hours of content. I hope you loved the sessions, okay. You might have seen something new, my visualization, my animation, the way that I approach problem solving ability and all. Okay, this would be very helpful to you. This will be always available in XLR channel. That will be it from my side. Okay, with this I'll be giving it over to Amar sir, our host. He will be giving you the details about exam and other things. And I hope we get connected on LinkedIn. We will, if you ever need anything, if you need any other guidance in learning DSA or any internship, full stack web development, graphic designing, you can always contact me. I'll be always there to guide students. So you can always get connected to me, and you can explore other courses in XLR as well. Okay. That's it from my side, from this entire training. Thank you for attending. Thank you for being dedicated and listening to my lectures. I'll see you again in some other course. Okay. Yes, that's it. I'll over to sir. You can take it over. Hello, sir. Yeah.
Yes, sir.
Yeah.
Yeah. Thank you so much, sir, for your
Yes.
valuable time and guiding the students.
Yes. Whenever you need anything, you need to know about me, just you can get connected on LinkedIn. And if you want to get to your DSA journey, just go with the bind 150 in NEET code. Okay, you can also call it NEET code, and just 1 question per day, 1 hour per one, all possibilities, learn about complexities and all. A lot. Okay, that would be, yeah, fine. So, is it okay now? Close.
Yes, sir. Actually, it was not linked.
I was just saying, students. Now it's fine, sir. Now it's okay.
Yes.
Yeah, so please take it.
Okay. So, hello everyone. Good evening. I hope my voice is clear. If yes, can I have a quick confirmation to the chat box? So, dear writing minds, ladies and gentlemen, girls and boys, it's time for a test. Okay. So, let's have a quick test of 30 questions. How much minutes? 10 minutes fine for you guys? How much minutes you want? You don't want test only? Is it like that? No answers? No responses? Okay, so I will give you the 25 minutes. 30 minutes, not at all. 25 minutes sufficient, more than sufficient. Okay, so I'm sharing the test link here in the chat box to everyone over the Zoom and YouTube as well. So, dear participants, your time start now. So, you're not having 25 but around 23 minutes. So, as I shared the link at 8:22, test will be closed by 8:45. Okay, so, okay, yeah, thank you, Rajesh sir. So you guys have to make sure that by 8:45, everybody must submit the test without fail. Okay, I already shared the link. Let's go ahead, submit your test, and all the best. And on top of it, no one will ask me for the attendance link until test is going to close, or else I will not share the attendance link for any one of you. Okay, thank you. Go ahead, guys. Let's submit the test. those who are here for attendance, they can leave the session because no issue. If you miss your 1 day's attendance, I think test is not important for you, right? Those who are joined for the sake of attendance, then this will only happen. Exam link, assessment link, right? As it's attendance time. I will be not sharing the attendance link until the test close and rest of things done. So please take care of that. Those who are completed, good job, guys. So you can share your marks here. Good job. 30 for 30. Wow, nice, Anjana. All 30 out of 30. So you understood everything as per my understanding. First thing. Second thing might be test paper is too easy. Or else then you did some and proctoring. What was actually the reason? May I know? Such it's too easy. Okay, fine. I think it's hard only, but after the training, then it's got easy, right? Acha, easy. Most of them are told ones, so right. Okay, trees. So it's a bit easy. Nice, guys. Okay, so those who are done with the test, well and good for rest. You guys have 10 more minutes, 11 more minutes, so you can take a time. Meanwhile, if anybody have any query, any question, if anything would like to share with us, any feedback, rest of attendance link. Okay, so you can ask me here in the chat box. Chalo, so stage is yours, guys. Come on. Yeah, you can ask me anything. Sir, how we should download the certificate? Definitely, I am going to cover that point. Before that, I am going to have one task. So after that, I will definitely give you the context on the certification, about the upcoming programs. उनका सालों के 14 is not good marks. So it's not about bad. Okay. So it's around 50%. So fine, not an issue. So if we are here at learning stage, if we have done everything on your own, not an issue. We are not here to judge anyone, right? There is no any competition with anybody. Our competition is with us only. So we have to check, be like, oh, okay, so last time I was here, I'm understood that part. So next time, which opportunity I can grab, which will help me, right? Sir, you give me a DSA complete roadmap. So see, so you have to connect with the technical person for the same, okay? 29 out of 30. Okay, Sneha, good. Okay, part 27, Yamini 30, 23. Priyansh 25. IUJ. So which college is this, guys? IUJ. I'm just seeing some full forms. Okay, Tanuja 30 out of 30. Sneha 29. ICFA University Jaipur. Oh, okay, got it. Thanks. 30 out of 30, 25. Guess, see, why you are keeping your name as a phone name? You have option to rename yourself. You have to rename. Okay. So how to call Vivo, Oppo, Realme? Again, attendance link. I said that I will be sharing attendance link in the last 5 minutes. So why to just do that? Rest of technical questions, guys. Okay. I already said that. Anything about the certification, I am going to explain that. So nothing to worry about that part. Yes. Again, Shiva Dharmaraj, you are in too much hurry. Same questions again and again. Let's wait. If anybody joined now, still you have some minutes, you can also attempt for a test as Sikandar Kumar from Bhopal. If you have any query or any question, you can post in the chat box. Raising hand will be not solve that. Similarly for Samiksha as well, because uh, the unmuting option is not available for you. So just drop here in the chat box. See, Akshat, the end of the day, language will give you the job. I'm completely agree. Like, let it be a Java developer or Python developer. But the logic building is something is very important. Okay, so A plus B or B plus A, the answer is going to some, right? Like the important thing, your logic building is important. So always like start from scratch, solve the more you practice, more you build. So in that scenario, you have to go. Sir, kindly share the PPT that was discussed by Rajesh sir. It was very informative. A PPT, I'm not sure on that part, but whatever the coding files as a PPT, you can always report the recordings or the portal or YouTube. But as a part of coding files, sir already shared that, and I think it's already published by the team over the LMS portal. Okay. Let me check some comments over the YouTube as well, or else they will be angry on me that I'm just replying to the Zoom participants, right? Last day, yes, today is last day. Attendance link, yes, you have to wait for some time. As I said, that 5-6 minutes, 10 minutes, not more than that. So, guys, what such programs it will be helpful for you in the future as well. So, you can just give us the suggestion. Definitely, there will be lots of program monthly we are having in a sequence. So, now you're done with the DSA, right? We are already going, sir, how should we learn from which channel? See, so currently whatever program we are done, that is available on the XLR channel. Okay, so currently we are done with this program. Okay, so that is DSA for progress companies. One more program that is currently ongoing, that with the DSA master with Java. Again, from 9th March, we are going to start the CRT program. So guys, you know that why CRT is important, right? Campus recruit. So whenever most of companies want to sort Vivo V2509, I said that multiple times, don't ask for the attendance. Then why you guys are asking for the attendance again and again, right? Currently exam is going on, others are submitting the exam. So please have some patience. Okay. So I'm just explaining about the upcoming calendar of XLR. So in a like upcoming week or upcoming month, we have CRT program. Okay, and after that we are going to have the digital marketing. So take a CRT as well seriously. Why? Because whenever you are going to attend some interviews, mostly MNC companies will definitely ask you to go from the apti round, right? Or mostly a mid-level company as well. Nowadays, like if we want to get a good students, then it will start from FT. So definitely, I'm here to welcome you all of you for that CRT program as well, which is scheduled to start from 9th March 2026. I will be sharing that registration link as well. Sir, please arrange a session on DDA. Okay, topic it will be very for again deeper understanding. Yeah, sure. So I will take a note of that as a suggestion. Definitely will try for this. Arpita, same videos you can check onto the XLR LMS portal, or else you can watch on the XLR YouTube video as well. Let me check that the same person is there. Now I'm not going to help on that. What is the issue? Yes, that is available. So Xiaomi T23076 RNBI. Bye bye. Guys, don't worry. Those who are not interested to let others submit the test, they can leave. So they said that if others are submitting the test, so you guys have to at least wait for some time, right? Yeah, I can just not tolerate that again and again after explaining so many times. Shubham Jain, Snehal Vijay Chaudhary. Is any course or class available from XLR? Yes, Pawan. So we have different courses and reader sector in this program in CSR activity. So like we are available in 7 to 8 different cities across the India, like Bangalore, Hyderabad, then Pune, two branches at Vimannagar, Pune, then Mumbai, Thane, Andheri. Cybersecurity, Shubham, we recently completed. Okay, so that will be there, but it will take some time. Girish, I'm not technical person, so I'm sorry for that. Few people will not understand normal English. Okay. Okay, fine. So, guys, those who are submitting the assessment, last 2 minutes for you. Okay, so just make sure that you are submitting your assessment on a time. Okay, then I will be having some explanation part as well. 30. Good, guys. So I'm going to give one task. So let me share for first attendance. Okay, so those are in hurry, let them leave. But those who attended regularly, be there. I have something to share about the certification and a few things as well. Wait. Let me share the attendance first. Just a moment. Allow me to get the link. YouTube participants are there. See, in simple English, I say that I will share the attendance link. Then what else I don't understand? It's just like you guys are creating a scenario. See, I know that certification is important to showcase that you are done something. But if you are not going to have the knowledge, certificate only will not help you. So gaining the knowledge, which is something important. Okay, so I hope like those who are just dropping same message, it's for them. So what is important, what is not important. So what we have to keep on first priority, right? So no one is interested to share any feedback on the sessions what were done on the 15 days, but everybody is interested to get the attendance link. Finished her 14 out of 30. Okay, good, Kushi, good. Kelvin. Okay, others guys, done with the test. It will be closing in 1 minute. I will extend 1 minute of time for you. If anybody is still submitting that, let's submit. Knowledge is more important. Yes, exactly. It was amazing. Thank you so much. Session is so good so for us. Super. Okay. Abhishek, what you're saying sharing here? There's no any reason to share such links, right? Okay. Just moment. Let me share the attendance first, and then I will assign one task for you guys. So the web development course is available. So see, there will be the different courses. What I will do, so I will be sharing one registration link. You can keep that bookmark on any of your platform, and definitely as per your. Okay, Abhishek Kumar, thanks, and here it's. Those who not listen to this. Yeah, attendance link I already shared. So you can just scroll up your chat a little bit above and you will find that. So others guys can stay back. I have some tasks for you. The 15 days course was extremely well structured and informative. The teaching was excellent and the concept were explained very well, clear and easy to understand manner. Thank you for the valuable learning experience, Mr. Rajesh sir. Yeah, thanks. Thank you so much for the comment. And definitely with this positive comments, positive vibes will be coming back again with the currently we are running another programs too, but definitely in the future as well, we will have many more programs for you guys. Okay, so now attendance I shared. I hope everybody received that. Okay. So Priyanshu, like as I said that I'm not having that much understanding on that part as being a technical person. So I can't make any false commitment. So if anything is related, rest of that from the Excel site. So yes, definitely you can ask me. Okay, so now, so guys, sir, can we have aptitude? Yes, yes, yes. That what I said, you guys. So from 9th of the March, we are going to start the CRT program. In that, aptitude will be covered. And you know that, like cracking the interview before going for the cracking interview, it will they will ask you. They will means every company mostly they will ask for the crack first aptitude. So keeping that things in mind, and you are going to couple of you are going to face the interviews very soon. Your current journey is be like from classroom to you're going to join the corporate, so definitely that's going to be helpful for you. So let's join on 9th of March again at same time with 7 p.m. You can register, you will get a mail for everything. Okay, so yes. Okay, so now I have one task for you, right? Okay, now I have one task for you. I'm sharing one link, a feedback link, which everybody need to mark, everybody need to click on that, and you need to submit your feedback about the session. Feedback not about this particular session, but feedback about the last 15 days session. Okay. I'm sharing the link. You have to enter some important words, how you felt, the positive words about the program. And I'm expecting for each one of you to submit the form or submit the feedback with the faster rating. Okay, so I posted that over the Zoom. I'm just posting here over the YouTube as well. So this task for you guys. Okay, so let's provide that as the feedback from your side. So that will be helpful for us to come up with the such more programs. So yes, so let's go ahead. Take your time of 2-3 minutes. Submit your feedback and get back to me that is done. And meanwhile, I will just arrange the registration link for your next program as a CRT. My attendance done, sir. Okay, thank you. Sir, tell me when we'll get the certificate of this course. Yes. Last but not least, definitely I'm going to take that query as well. I will be definitely going to see each one of review as we are part of the training program from last 15 days. I have given the feedback in last SDP. Okay, Prajwal, thank you. Thank you, Prayas. Thank you, Chetna. Thank you, Rahman. Thanks to all. Okay, once all done, then I will share the registration link. I will give you some more things, and then maybe by as usual by 9 we'll wind up for the day. Yes, exactly. So we have 9 more minutes. Yes, yes, yes. Ashmita Roy, Arti Walekar. I will explain about the certification. No need to worry. Okay. Or you want to hear it now only? Okay. So I think yeah, it's time for food. Waiting. Okay. No problem. So coming to the certification, guys, those who submitted their attendance come feedback form for 60 and more than 60%, they will be receiving their certificate within 8 to 15 working days via registered mail ID. I'm just going once again with the same announcement. So listen me carefully. Those who attended 60 or more than 60% of the session and fill the attendance and feedback form, they will be getting certificate within 8 to 15 working days via your registered mail ID or the mail ID which you use at the time of submitting the attendance. Clear? I hope it's clear like a crystal, right? Now, anybody, another doubt, any query, any question? Okay, so I'm just sharing the feedback link once again. So if anybody missed on that, and now I'm going to share the one more thing that is about the registration link. So guys, as I said that you will bookmark that registration. So the calendar will be always up because our tagline is everyday learning. Okay, so every day something will be there for you. Be in touch and definitely it will be helpful for you because we have industry experts with us. Already submitted the attendance, not an issue. If you submitted, not an issue. How to check your attendance? Yes. So you have to apply the formula to check your attendance percentage. Total number of sessions you attended divided by total number of session planned into 100. That's it. Simple mathematics. If you attended 9 sessions out of 15, then as per my understanding, so then you will be eligible for certificate. Yes, I will be sharing the feedback link once again, Tanvi, not an issue. So meanwhile, I shared the XLR free course registration link here as well. So just bookmark that. And again, welcome to you for the next program. Yeah, I said that Chinmay Sai, right? I just said that I will be sharing that. I will be sharing. No need to worry. All this, I heard from few of you only that you are done with the review. Why? See, currently, whatever courses are there, you can check on that registration link, Arti, and you can definitely register for that. Dancer, dancer, dancer. Okay, super. Yes, so I am done with the almost of my announcement. No issue. So see, which form you are saying, which form you fill with the different mail ID, I don't know. You are saying that registration form. If yes, you can, whatever like you already have. Sir, I have filled the feedback form. I have marked the attendance along with the test. So can I go? Need to have a dinner. Yeah, you can go, but I just want to ask, like you submitted the review. So yes, you can definitely. Registration link. Yes, I'm just resharing that. Sir, where are you from? Yeah, I'm from Pune, guys. Okay, so I'm working from the Pune branch. Yes. Thank you so much, sir. You're welcome. Plus, what, Sanika? What plus? No problem, sir. Feedback is completed. Thank you. Yes, registration link I reshared. Thanks for conducting such amazing 15 days lecture. You're most welcome and would like to see you again for upcoming program. Yeah, if you're not able to find that, Sikandar Kumar, then you can submit other and you can write it down as a PDF. By mistake only, sir. Oh, okay. No problem, Sanika. In 15 days, Madhu. Okay, in 15 days, you will. Feedback is complete, sir. Yeah, thank you. Thank you, Sweta Shri Roy. Sir, how I can join other courses as well? I shared the registration link there, right? So register there, you will get the detailed information. So when the classes are going to start, the joining link, everything, it will be there with you. And yes, definitely you have to new program, new registration, right? You need LMS access, right? You need to get the notifications. Then you can just take 30 seconds. Sir, you all teach better than my college teachers. Yes, everybody is good. Yes, we have to always see a learning opportunity from each one of person. Let it be a teacher, let it be a tutor, let it be a visiting faculty, let it be our parents, or let it be our colleagues or students. Everybody is having something unique. We have to take that positive note. Okay, so from today, in today's session, I learned that how to talk or how to present, what things are there. So small things will support us to build ourselves, right? At end of the day, no one is going to be there with you while giving the interview. So you need to gain the knowledge. You need to build yourself, right? Your session is good, sir. Excellent. Yeah, thanks. Which course include aptitude sessions? So, in aptitude, mostly we are going to focus on to the quant, logic, verbal, and on top of it, we'll try to work on some questions in a apti, which will be there to crack the interview. Sikandar Kumar, no need to raise a hand. Please drop a message. It's my second request to you. Thanks. SDP program on Power BI. Want to apply this course? This is already over. I'm so sorry for that, but it will be there again in the future. You're welcome for that. So, what is the program name for next session? So that is CRT, Campus Recruitment Training. Okay, Student Development Program on CRT. Campus placements, 9th March, 7 p.m. to 9 p.m. You participants, anything? Certificate is not coming, sir. Which certificate, sir? Certificate after 8 to 15 days. I said that, right? You will get on a mail, Aarti. I said that already, right? Okay. So it's 9. Thank you so much, guys. And it was very important part that you are here from the day one, and you got some good knowledge from our side, right? I'm just thanking you all for making this program successful, because without your support, without your interaction, that's not possible. So thanks to you as well. And no need to miss the sessions. We are coming back again, and we'll be coming again and again. Okay, so happy learning with XLR. Thank you so much, and all the best for your future plans. Keep coding, keep developing yourself, and trust on process. Everything will be there. Okay, so your host Amar Shavte winding up for the day here, and thank you so much from the team of XLR for attending the session. And once again, happy learning with XLR, guys.